Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the sensor, its types, characteristics and data formats. What is meant by sensor? Sensor is a device that quantifies the nature and the distribution of surface materials by measuring electromagnetic energy that may be reflected or emitted. Here, the remote sensing process, which includes the steps from energy source, propagation, interaction, recording. Sensors are a critical component of the remote sensing process where they are linking with the energy source, atmosphere, target, and data acquisition system. Means it quantifies the nature, condition and distribution of surface features by converting that energy into usable digital information. With reference to civil engineering point of view, that sensor data which supports for the mapping activity, site investigation purposes, infrastructural planning and environmental monitoring. The passive sensors and the active sensors are the two types of the sensors where passive sensors here they are dependent on the external energy sources such as sunlight or naturally emitted thermal radiation from the Earth's surface. They record reflected energy in the visible and near infrared regions, which emitted energy in the thermal region. For example, it includes photographic cameras, multispectral scanners, and radiometers. So the principle of passive sensors which depends on the external energy sources with the source of visible or near infrared region or thermal region radiations. With reference to the civil engineering point of view, these type of sensors are most useful for land use mapping and land use cover, vegetation cover assessment and water resource studies, which includes the photographic cameras and multispectral scanners and radiometers to collect the data. Second one will be the active sensors. They are self-generated illumination, or we can say that the active sensors which generate and transmit their own energy and measure the return signal on backscattered from the target. They are mainly operated by the microwave region and they are independent of the sunlight. So major advantages which include that the day and night operation and the ability to penetrate cloud cover. These examples such as radar, SAR, LiDAR are widely used for terrain mapping, flood monitoring and infrastructural assessment purposes. Next one most important, that is the imaging and non-imaging concept. That means the data formats. So imaging sensors and non-imaging sensors are useful for the both processes of imaging and non-imaging. Imaging sensors create two-dimensional images by scanning, or we can say that the capturing the earth surface systematically as explained in the picture 1. Their output is stored as a digital raster grid containing pixel based radiance values, where non-imaging sensors generate point measurements or any profiles instead of any image. Just like the example which includes the radiometers, altimeters and scatterometers. They are used in the elevation measurement, roughness analysis and environmental monitoring, etc. Likewise, that imaging sensors and non-imaging sensors are used to store the data with reference to the 2D or 3D condition or the graphical representation which is required for the analysis purpose or data collection purpose. Next one will be the optical scanning mechanism. Here the two tasks are there: across track and along the track. So here across track means whisking broom and along the track means push broom. For the example, that is Landsat MSS of across track, where spot HRV, IRS, LISS and many more for along track. Means across track scanners use a rotating mirror to scan the earth surface line by line, but the along track scanners use a linear detector array to capture an entire line simultaneously as explained in the pictures. So push broom system, that is along track system, which provide longer dwell time and improved radiometric quality. Just like example which include Landsat MSS, whisk broom and Spot HRV IRS leases, Landsat 8 for the push broom. So whisk broom and push broom, these are two optical scanning mechanisms or scanners which are available to scan the data with reference to the geodetic curvature across track, which is based on the line by line scanning, but the along track which have some path to scan at a time. Next one will be the thermal sensing systems, which is based on the principle which detects radiant temperature, or we can say that the emitted infrared rays based on the kinetic temperature of objects. These thermal sensors detect that emitted infrared radiation and measure the surface temperature of objects with the atmospheric windows for thermal sensing occur in the 3 to 5 micrometer and 8 to 14 micrometer wavelength regions. So specialized detectors such as explained in the HGCDTE, these are the nomenclature for the detectors. They are nothing but a photon detectors, are used to capture thermal energy. With reference to the application point of view, the civil engineering applications which include that we can use it for the urban heat island analysis, thermal population or thermal pollution studies, and moisture stress assessment or any analytical approach. Next one will be the radar, that is microwave sensors. Radar is the radio detection and ranging, which is an active microwave sensor that transmits and receives electromagnetic waves. Here, the synthetic aperture radar, that is SAR, uses satellite motion to achieve high spatial resolution. Based on that radar, the backscattering, which is depends on the surface roughness and dielectric properties such as moisture content. With reference to civil engineers, that radar is useful for flood mapping, landslide monitoring, deformation studies, and all-weather terrain analysis, and many more usage. Next one will be the sensor characteristics, that is resolution base. So spatial resolution, radiometric resolution, and many more type of resolutions we can use it. But here the spatial resolution, which defines the smallest object that can be identified in an image and is represented by the pixel size. Radiometric resolution indicates a sensor's ability to distinguish small differences in energy levels. The instantaneous field of view, or we can say that the field of view, determines the total ground cover or the swath width captured by the sensor. Resolution characteristics directly influence the accuracy and the usefulness of remote sensing data with reference to the engineering projects. Here, the comparative study of the characteristics, which is explained in the tabulated format based on some features like altitude, orbit, repetitive cycle sensors. So Landsat satellites operate in near polar orbits, approximately 705 km altitude with 16-day revisit cycle. Different generations have carried like MSS, TM, OLI, and TRISS sensors. These are the nomenclatures for sensors with reference to its separate or distinctive objectives for multispectral observations. The Landsat program evolved from whisk broom technology to modern push broom systems. Civil engineering applications point of view, if we see that technologies are most useful or Landsat 1.3, Landsat 4.5, Landsat 8. Likewise, for land use mapping, land use cover, zoning purposes, then watershed management and analysis purposes, urban growth analysis purposes, we can use it as a civil engineering domain. The characteristics of Indian remote sensing sensors by the ISRO, they are also explained in descriptive manner based on some features, that is that satellite provide high quality earth observation data for resource assessment and infrastructural planning, that sensors offer varying resolutions and the swath widths. The pan sensors provide high spatial resolution while the Wi-Fi offers wide area vegetation monitoring. With reference to the civil engineering purposes, that Indian remote sensing sensors, they are most useful for the road alignment marking, groundwater studies and urban planning point of view. Also somewhat we can use it for project monitoring also. Here the major satellites, that is spot and high resolution satellite system. The spot, that is systematic power observation delatory, where that satellite operates in sun synchronous orbits and they are equipped with high resolution visible sensors, a unique feature which is of nadir viewing capability, which allows stereo imaging and rapid revisit coverage in the spot. The commercial high resolution point of view, we see that the quick world and world view, that is, will provide sub-meter spatial resolution. This system supports detailed engineering survey, corridor mapping, and urban infrastructural planning. With reference to that, characteristics of spot, satellite, and HRV sensors, that is high resolution system. The comparative analysis of swath width. The swath width, which represents basically the width of the ground area which is covered during the single satellite passes over that space. Wide swath sensors provide large area coverage but generally lower spatial detail. Narrow swath sensors provide higher spatial resolution which is suitable for detailed investigations. Just explain with the bar chart of swath width in kilometers with reference to the types of satellites which are available. So here the swath width is more for IRS WIFS, that is 810 kilometer, but for minimum, that is quick bird, which is only for 16.5 kilometer. Likewise, we can comparatively analyze that swath width with reference to the type of satellites. So with reference to civil engineering domain, the coverage of area and the details by the civil engineers which useful and appropriate to select a sensor which is more required to balance between coverage area and mapping detail. The comparative analysis of revisit time point of view, we can use here temporal resolution, that is low weight, that is standard orbit, long width standard orbit, and rapid access AGL system. So effect of steerable mirrors, which is most important with reference to satellite and with reference to the duration point of view. Here that revisit time refers to the interval basically between successive observations of the same location. That is, AGL satellites with steerable sensors can reduce revisit time significantly through off-nadir viewing. The short revisit periods are important for monitoring rapidly changing environmental conditions. The applications, which include disaster management, construction monitoring, and flood assessment with reference to the infrastructural surveillance point of view, we can use that analytical terms basis of off-nadir or nadir with reference to the remote sensing system or with reference to satellite system. The summary and the engineering applications point of view, that is the precision engineering editorial, where high resolution optical sensors support town planning, land use mapping, and urban infrastructural development. That stereo images or imagery satellites such as spot, which helpful in the road and railway route alignment studies. Active microwave sensors such as radar are highly effective for flood mapping and water resource monitoring point of view. The width point of view, we can use the swath sensors such as support disaster management applications which include cyclone tracking, hazard assessment, and emergency responses, and many more. Stay tuned guys, happy learning.